Alrighty, boys and girls, welcome back. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School, and in this video, we're finishing out our probability section of Unit 3, and we're gonna just do this warm-up for our wonderful Turbo Tuesday. So it says, Eric and Sue will randomly select from a treat bag containing 6 lollipops and 4 gumballs. And so anytime you can have this, you can always kind of draw out your sample space. So I'm going to say, let's say this. I'm going to have 1, 2, 3, 4, 5, 6, and then I have 4 gumballs. So 1, 2, 3, 4. Okay. Get that on screen for her. There it is. Alright. So it says Eric will select a treat, replace it, and then select another treat. So when you're doing this, you know that you can use those keywords to say, hey, I know that when Eric does it, it's going to be independent. Meaning, since he's putting it back, that denominator is not going to change. However, when Sue will select one, she will not replace it, which means it is dependent. Then it says, who has the higher or the greater probability of selecting 1 lollipop and then 1 gumball? Alright, so let's do that right here. So let me zoom in a little bit more. Alright. And what I did is I kind of broke it into 2 sections. I said Eric and Sue. Again, we said Eric was independent, where Sue was dependent. Alright, maybe get it small here. It's easier to write with. Alright, so when we're working with Eric's, what are we looking for? We're just trying to see, okay, what's the probability of picking a lollipop? So again, it's always the count of the event. So how many lollipops do we have? We have 1, 2, 3, 4, 5, 6. Out of the 10 total items. So it would be 6 out of 10, which is equal to, let's say, 3 over 5. Since he puts it back, again, we don't have to eliminate it. And so that means it will have the probability of picking a gumball is going to be 4 out of 10, which is the same thing as 2 over 5. As always, make sure you multiply them together. So we have probability of picking a lollipop and a gumball. Again, are these 2 probabilities multiplied together. So we're going to have 3 over 5 times that 2 over 5, which gives us 6 over 25, which is the same thing as 0.24. Let me move this up a little bit more. There we go. 0.24, and we can also have that percent, so that way it's a little bit easier to see. Let's say 24%. Okay, so that was Eric. Let's see what Sue will get. So let's do, I'm going to do blue for Sue. And so, a similar setup, we're going to say probability of picking a lollipop. Well, that's actually going to be the same since we're starting with the same sample space. So we already know that's going to be 3 over 5. However, if she takes that 1 lollipop away, again, I'm going to erase it because I'm not replacing it. So that means this, when I go for the probability of picking a gumball now, it has to be gumball after. Picking a gumball after a lollipop is taken out. How many are left? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have a total of 9. And there is 4 gumballs. Again, it's in the numerator, it's always the count of the event. In the denominator, it's the total count, meaning how many treats do we have in total is in the denominator, how many gumballs do you have in the numerator. All right. Lastly, multiply these two together. So we're going to say like this. I'm going to say a probability of picking a lollipop and a gumball. Again, this is for Sue, so it should be a little different. And you can notice that by these two fractions. Multiply these two together. 3 over 5 times that 4 over 9. Well, let's see what we end up getting. Should get this equal to 12 over 45. When you simplify that out, you should end up with something like this. It should give you this is equal to, has 0.266 repeating. Again, we always round to that nearest percent, and so we're going to say it's about 27%. So now, out of these two, Sue's probability will be greater. You can always make sure you can read carefully for those questions.